Imagine a reptile walking the earth today, a direct link to the age when dinosaurs ruled. New Zealand is home to such a creature, the tuatara. Despite a strong resemblance to lizards, it represents an entirely distinct order of reptiles called Rhynchosphalia. This lineage stretches back an astonishing 240 million years, predating the earliest dinosaurs. The tuatara is the only surviving member of this once diverse group, making it a truly unique branch on the tree of life. During the Jurassic period, the tuatara's relatives were the dominant group of small reptiles worldwide, boasting a variety of forms. But over the Cretaceous, this order saw a significant decline. Competition from mammals and the rising dominance of lizards may have played a role in their fading presence across the globe, leaving the tuatara isolated in New Zealand after it separated from the ancient supercontinent of Gondwana. While you often hear the tuatara called a living fossil, it is a term many scientists view with caution. Yes, the tuatara has retained many physical characteristics of its ancient ancestors, offering a glimpse into deep time. But it is crucial to understand that the tuatara has also continued to evolve over millions of years. Its survival is not because it remained unchanged, but because it adapted to its specific environment. Perhaps one of the most striking features is its head. The tuatara possesses a unique jaw structure found nowhere else among living species, with a double row of teeth in the upper jaw fitting over a single row in the lower. Its teeth are fused directly to the jawbone and do not regrow. As they wear down, older tuatara shift their diet to softer fare. Adding to this marvel, the lower jaw slides forward after closing, creating a powerful shearing motion perfect for cutting through tough insect exoskeletons and small bones. Its skull also has a solid bony bar behind the eye socket, a trait found in ancient reptiles, which seems to stabilize its powerful bite. Look closely at the top of a tuatara's head, especially in hatchlings, and you might spot a small, translucent patch. Beneath it lies the parietal eye, often called the third eye. This unique organ has a lens and retina, but it cannot form images. It is connected to the pineal gland in the brain and plays a role in regulating the animal's circadian rhythm, its daily cycles of activity and rest. It also likely helps detect light intensity, assisting with seasonal timing and thermoregulation by gauging the sun's position. The tuatara's senses and skeleton hold more surprises. It can hear, but lacks external ears or eardrums. Its primitive internal hearing organs primarily detect low-frequency sounds. Its spine features hourglass-shaped vertebrae, common in fish and amphibians, but unique among living amniotes like reptiles, birds, and mammals. It also has gastralia, bony rods in the belly, and small hooked bones on its ribs called uncinate processes, features seen in crocodiles and birds, suggesting a deep, shared ancestry. And yes, like many lizards, it can lose its tail to escape a predator, though regrowth is a slow process. This is not a fast-paced creature. Tuatara thrive at temperatures significantly cooler than most reptiles prefer, staying active even when it is just 5 degrees Celsius. Their optimal body temperature is a cool 16 to 21 degrees. This slow metabolism contributes to an incredibly slow growth rate. They keep getting bigger for the first 35 years of their lives. This slow living seems linked to remarkable longevity. While 60 years is a common lifespan in the wild, many live over 100. And one famous male, Henry, became a first-time father at 111. Some experts believe they might live up to 200 years in captivity, potentially thanks to unique genetic traits that protect their cells. Reproduction is a patient affair for the tuatara. They take between 10 and 20 years to reach sexual maturity. Females reproduce only every 2 to 5 years, a remarkably slow cycle. Courtship involves the male displaying by darkening his skin, raising his crest, and walking stiffly around the female. They do not have external reproductive organs. Sperm transfer occurs via a cloacal kiss, similar to how birds mate. Adding another layer of intrigue, the temperature at which the eggs incubate determines the sex of the hatchlings. Warmer temperatures favor males, while cooler ones produce females. On their isolated island homes, tuatara often coexist with burrowing seabirds like petrels. They frequently take up residence in the birds' underground nests for shelter. The nutrients from bird droppings support a rich invertebrate population, providing a steady food source. Tuatara primarily prey on beetles, spiders, and wettas, but they also eat bird eggs and chicks, and occasionally other small reptiles. They are territorial, defending their space with determined bites. For centuries, the tuatara clung to survival only on predator-free offshore islands. They had vanished from mainland New Zealand due to introduced species like the Polynesian rat and habitat destruction. But a new chapter is being written. Intensive conservation efforts, particularly rat eradication on various islands, have allowed populations to recover. More recently, tuatara have been reintroduced to heavily protected mainland sanctuaries. In 2009, an exciting discovery confirmed that tuatara were successfully breeding in the wild on the North Island for the first time in over 200 years. This is a hopeful sign for the future of this ancient reptile.